Hi, welcome to my video on mapping notation on ordered pairs. This is the first video in the unit on transformations on ordered pairs. A mapping rule can be used to describe the relation between two ordered pairs, x, y. The right side is an image of the left side. The left side is xy, so the right side, which is an image, is x plus 1, y. We have an image, or left side is xy, then the image is x, y minus 2. xy mapped to x, 3y. So notice the x is increased by 1, the y is decreased by 2, and the y value is tripled. Find the value of the image in each ordered pair. So we have a mapping rule that says x, y maps x minus 4, y. So that's a 7. X is 7 minus 4, 1. And that becomes a 3, 1. And here we have negative 3 minus 4, 2. Notice the y is not changed. And so the ordered pair is negative 7, 2. Number 2, x, y mapped to x, negative y. So the x is not changed, but the y is the negative. So 3, negative 3. The x is not changed, so the x is a negative 1. And the opposite of a negative 9 is a plus 9. Number 3. The mapping rule x, y is mapped to x 4 times y. So the x is not changed, so the x is 0. And 4 times 2 is 8. The x is not changed, the x is 1. 4 times negative 5 is a negative 20. And the mapping rule x, y is mapped to x plus 2, 3y plus 1. So the x plus 2, so it's a negative 4 plus 2, and it's 3 times negative 6 plus 1. So the ordered pair, negative 4 plus 2 is negative 2. We multiply and then add, negative 18 plus 1 is negative 17. And we have x plus 2 with the 3, so it's a 3 plus 2, 3, y is 2, so it's 3 times 2 plus 1. Oop, make that bigger. So that's a 5, add on, 6 plus 1 is 7. So transformation is very important when we're dealing with graphing and how a function is transformed into a new image. The mapping rule can be used to describe the relationship between two tables of values. Let's use the set of all x and y such that x and y belongs to the integers. Map the table of values using each mapping rule below. So this table of values is, as you can see, is 2, 2, 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2, x and y. So we have a table of values, so we go with this table, x. The mapping rule xy is x plus 4y. So we're taking the x and we're adding a 4, but we're not changing the y. So this is x plus 4y, so that's a 6 plus 2. So we're adding 4 to the x value, but we're not changing the y. And we take the 1, so it's a 1 plus 4, 1. So that's a 5 and a 1. And we're doing 0, 0. So it's a 0 plus 4 and a 0. So 0 plus 4 is 4 and a 0. And we have a negative 1 plus 4, negative 1. So that becomes a 3, negative 1. Negative 2, 2. X is negative 2. Add on 4 and y is negative 2. So that's a 2, negative 2. So notice in this mapping rule, we're adding 4 to the x, but not changing the y. So the y value is 2, 1, 0, negative 1, negative 2, stayed the same. And we're adding 4 on to these values. So that's, as you can see, that's a add on 4 is a 6, 5, 4, 3, 2. And we have another mapping rule, x comma y, map to x and y minus 1. So we're taking 1 off the y, but not changing the x. So we're not changing the x. I just write these down. So we're not changing the x, but we're adding, subtracting 1 from the y. So 2 minus 1. So this is x, y minus 1. So that's a 2, 1. And we're taking 1 off the y. So 1 minus 1 gives me, that's a 1 and a 0. We got a 0 for the x. And we have a 0 minus 1, which is negative 1. We got a negative 1. Negative 1 minus 1 is negative 2. The x is negative 1. The x is negative 2. And so negative 2 subtract 1 is negative 3. Again, the x value is never changed. 2, 1, 0, negative 1, negative 2. 2, 1, 0, negative 1, negative 2. And the y values, we subtracted 1 from each y value. So they're 1 less. 1, 0, negative 1, negative 2, negative 3. And here we have both of them changing. So let's just do this first. We have 5 ordered pairs. So this is x minus 2, negative 3y. So let's do the x first. X minus 2. So we got a 2. We got a 1, 0, negative 1, negative 2. And we're subtracting 2 from the x's. So the x is 0, negative 1, negative 2, negative 3, negative 4. And the y is 3 times the y value, so it's negative 3 times the y value. So the y is 2, the y is 1, the y is 0, y is negative 1, and the y is negative 2. So that becomes negative 6, negative 3, 0, 3, 6. And again, you can apply it to an ordered pair, but when you do a table of values, you apply it to each of the ordered pairs that you have. And now we're going to graph a set of x, y such that the x comma y belongs to the reals. So the difference between the integers are dots, and real numbers is shading. For each below, construct a new table of values and graph each table. So here we go. It's the same thing again. So the new table of values is x plus 2 and a y. So we're adding 2 to the x. So we're adding 2 to all of these. So 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. Negative 1 plus 2 is 1. Negative 2 plus 2 is 0. Notice you're adding 2 to these, so you can see that this is decreasing by 1, and you can see that this is also decreasing by 1 as we go down. And the y is not changed, so the y values stay the same as 2, 1, 0, negative 1, negative 2. So we're going to graph this now. Again, this is a set of x, y. And we're graphing. So let's graph 4, comma 2. X is 4, y is 2. X is 4, y is 3. Sorry, x is 3, y is 1. X is 3, y is 1. X is 2, y is 0. X is 2, y is 0. X is 1, y is negative 1. X is 1, y is negative 1. X is 0, y is negative 2. X is 0 here, y is negative 2. And notice because we have the real numbers and we're graphing, we can do a shading. Real numbers is a shading. So this table of values can only represent some of them, but then when I draw the line through all the ordered pairs, I have to do a shading. And B, x comma y, such that x is mapped to x and y is mapped to y minus 1. So this is x and this is y minus 1, so the x is not changed. So it's a 2, 1, 0, negative 1, negative 2. And the y value is subtract 1. So 2 subtract 1 is 1. 1 subtract 1 is 0. 0 subtract 1 is negative 1. Negative 1 subtract 1 is negative 2. Negative 2 subtract 1 is negative 3. And again, we plot all these ordered pairs. 2, 1, x is 2, y is 1. X is 1, y is 0. X is 1, y is 0. X is 0, y is negative 1. X is negative 1, y is negative 2. X is negative 1, y is negative 2. X is negative 2, y is negative 3. X is negative 2, y is negative 3. And again, we're graphing the ordered pairs, so we have to shade in. And if they were integers, they would only be dots. Okay, let's continue. If I can turn this page here. And we have more. Again, the mapping rule is x and a 2y. So we're doubling the y value but not changing the x. So the x is 2, 1, 0, negative 1, negative 2. The x value is never changed. But the y value is being doubled. So 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. And we plot this table of values. 2, x is 2, y is 4, which is right there, roughly. X is 1, y is 2. X is 1, y is 2. X is 0, y is 0. X is negative 1, y is negative 2. X is negative 2, y is negative 4. There it is, right there. And again, we shade in because we're dealing with the set of real numbers, we have a shading. And there's the graph to represent this mapping notation. And so we have another mapping notation, x comma y maps to x negative y. So that's an x, that's a negative y. Again, the x is not changed. 2, 1, 0, negative 1, negative 2. The x is not changed, the x values, but the y value is the negative of it, so it's the opposite. So the opposite of 2, negative 2. Opposite of 1, negative 1. Opposite of 0 is 0. 0 has no opposite. 0 is neither negative nor positive. The negative of a negative 1 is a plus 1. The negative of a negative 2 is 2. So we plot these values. X is 2, y is negative 2. X is 2, y is negative 2. X is 1, y is negative 1. X is 0, excuse me. X is 0, y is 0. X is negative 1, y is 1. X is negative 2, y is 2. And we have noticed that that's the graph that represents, again, this is a shading because we're dealing with the set of real numbers. If we were dealing with the set of integers, we would only do the dots. So that gives you an introduction into the mapping notation, graphing ordered pairs, or graphing table of values. That's the first video. If you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.